Okay, so in this video, we're going to take a look at some sampling techniques and focus our attention on stratified sampling. So first of all, let me give you some context here, okay? If we are going to conduct a survey and ask people about something, right, then we all need to go through a process of sampling the population. Now, a population is all of the people that we're looking at, every single person. So if the population of England or the US, right, okay, of course it means population. If I'm looking at, I don't know, a football club like Manchester United, then the population is all of the supporters, right? It's the amount. Well, we can't ask every single supporter of Man United or every single person in the UK or America. That wouldn't be a appropriate thing to do unless you're creating a census. Well, instead, we'll take a sample of this population, and there's lots of different ways of taking a sample. So the most obvious and simple way is randomly, right? We could just take a random sample of people. Okay, that makes sense. We could also do it in some systematic way, because if we had a list of names, we could just take every third name or every fifth name, depending on the sort of sample size we wanted, right? That's known as systematic sampling. Or, and this is the focus of today's video, we could have a look at stratified sampling. And stratified sampling is quite clever because if we consider the way a population is broken down, perhaps by age or perhaps in some other way, then we can get the correct proportions into our sample, right? So for example, and let's just take a quick look at our first example we'll look at in a minute. We've got a school in England and they have grade 10, 11, 12 and 13 students there, look, right? And they want to have a sample of people which is evenly spaced out, so the correct proportion of year 10, 11, 12 and 13 students are in that sample. Well, they're going to need to have a certain number of 10, 11, 12 and 13 students. We can't just have any random amount. It's got to be the same proportions to get a fair sample, and that's the idea behind stratified sampling. So let's use this as a great place to have a really good example of how this could work. Well, step number one is always to add up all of the pupils in the school, right? Or all of the people you're looking for in your population. So if we add up 320 plus 300 plus 180 plus 150, we get a total of 950. Okay, so that's our first step. Now, the second step is to think about probabilities, right? And to think about the probability of selecting one of these pupils at random. So if I was considering the year 10 students, well, that would be, and I'm not going to simplify this, but it would be 320 out of 950, of course, right? And if it was year 11, it would be 300 out of 950. If it was year 12, it would be 180 over 950, and of course if it was year 13 it would be 150 over 950. So that's the probability, and of course it's unsimplified, of selecting one of these pupils from random. Now what I need to do is think about 50 pupils because my sample size is going to be 50. So I'm going to get each one of these numerical values, it's just a decimal or a fraction, and multiply each of these by 50. Right? So you can use a calculator for this, of course. Now, I'm going to need to keep a little bit of, I don't want to have too many rounding errors here, but I'm going to need to write a few decimal places out here. So I've done this, and let's just write these out. So 320 over 950 times 50 is 16.84. Our next value is 15.79. 180 over 950 times 50 is 9.47. And then that last one is 7.89. Now, what you will find if you added these values up and you did it precisely without any rounding errors, then this would come to 50. Now, what we're going to need to do, of course, is you can't have 0.84 of a person, of course, so we're going to round these to the nearest number. So 17, this is rounded to 16, this one is rounded to 9, and this one to 8. And here we have our answer. We're going to have 17 year 10 students, 16 year 11, 9 year 12s, and 8 year 13 students. Now, before we finish this question, we must just check that this does in fact add up to 50. So yes, in this case, it absolutely does, but sometimes it may add up to 49 or 51. And this is going to happen because you've got some rounding errors that are compounding this and making it a problem. So if that was the case, we'd have to look back and see which one is the furthest away from its rounded number, and we would round that in the other direction so that the numbers added up to the correct sample size. Okay, let's go and look at one final example. Okay, here we've got a company and they want to take a sample of their employees to discuss issues. So how many of each type of employee should they take if the sample size is 20? Okay, so let's focus in then on this box. How many managers? Well, the sum we need to do, first of all, we've got to add these up. If we add 8 and 20 and 12, 140 and 30, we get 210. Okay, so the sum we need to do for managers is 8 over 210 times that sample size, which was stated as 20. This comes out at 0.76, which rounded gives us one person for our sample. If we now consider the supervisors, we're going to need to do 20 over 210 times 20. Well, that's 1.90, and that, of course, rounded to the nearest whole number for our sample, comes out at 2. Administrators, well, it's 12 over 210 times 20, and that is 1.14. And if I complete this for the other, we're going to have with the other teams, we're going to have 140 over 210 times 20, which is 13.33. And then delivery staff, 30 over 210 times 20. Well, that's going to come out at 2.85. Rounded, these are going to be 1, 13, and 3. Just check, does that add up to 20? Yes, it does. So these are our correct numbers of each type of employee. Okay, let's finish this off. We've got our final question to think about at the end here. If a stratified sample contains 8 manual staff, what would be the size of the complete sample? Well, if we go back and think about the sum we did for our manual staff, it was 140 over 210 times that sample size. Now, that's unknown in this case. Let's just call it n. But we do know that when that sum was done, their answer was 8, because in this sample, we've got 8 staff. So what we're going to have to do is we're going to have to reverse this equation. So we'll multiply both sides by 210, and that will give us 140n is 8 times 210. Now we'll divide by 140. So the number we're looking for will be 8 times 210, all divided by 140. And if we work that out, it comes out as 12. So our sample size is going to be 12. Okay, I hope that you understood that video about stratified sampling. I'm sure you can access that question set now.